Hi, hello, what's up? Good morning, good day to everyone who's watching this video. So, my name is Charlene Alea R. Rivera. I am from BSc 3I. My subject is Dynamics of Rigid Bodies. So, one of the topics of Dynamics of Rigid Bodies is this rotational motion. So, let's start by giving you an example and solving this right away. So, for rotational motion, we have example number 2. So, the pinion A of the hoist motor drives gear B, which is attached to the hoisting drum. The load L is lifted from its rest position, and acquires an upward velocity of 3 feet per second in a vertical rise 4 feet with a constant acceleration. As the load passes in this position, calculate the acceleration of point C on the cable in the contact with the drum and the angular velocity and angular acceleration of pinion A. So as you can see, we have the pinion and the drum. So as you can see, we have like this, which is the gear. We have point C, we have the load, we have 3 feet per second upward, and 4 inches, 36 inches, 48 inches, and 12 inches, and we have 0.8. So let's start to solve this and let us find the knowns and unknowns in this given problem. So let's start. So let's start for letter A. So for letter A, when the cable does not slide on the drum, our vertical velocity and acceleration of load L, which is this one, this is our load L, you can see in the figure below me. So load L are necessary. We also have the tangential velocity denoted as v and tangential acceleration, which is at specifically at point C. So where is point C exactly? So here, it's located upward. So it's upward point C. So the normal and tangential components of the acceleration of C is, solution is for letter A specifically. So v squared, we have v squared equals to as. So acceleration is equals to a tangential v squared all over 2s equals v is equals to what? So v is equals to 3. Yes, it is given. So v is equals to 3, quantity 2 squared. So 2 multiply, which is our s in here. So our s in here is 4. So okay, 4. So 2 times 4. So calculating this, so we got 1.125 feet per second squared. So this is our acceleration. So we have acceleration normal, which is equals to v squared and r. So this is our form, and this is our also formula. So here, so substituting the values, we will now have for v same as 3 squared. Our r is 24. So where is 24 in the figure? Right there. 12 plus 48 minus 36, we got 12. So 12 plus 12, we got 24 for the r. So 24, so since it is inches, we will now convert it to feet. So 1 inch is equivalent to 12 feet. So 24, it's vice versa. So 3 squared, so let us compute that. 3 squared 24, 12, we got 4.5 feet per second square. That is our acceleration normal, guys. So after that, we have acceleration tangential, acceleration normal. So for acceleration tangential, 1.125 feet per second squared. Acceleration normal, 4.5 feet per second squared. So the next thing that we will do now, So for the next thing that we will do now is to get their acceleration. So just simply an squared plus at squared. So get the value, then substitute. So we have acceleration at point C. So acceleration at point C is equals to acceleration normal 4.5 squared plus acceleration tangential squared 1.125. No need to include the unit, so squared. So acceleration at point C, we have here square root of 4.5 squared plus 1.25 squared. We will now get 4.64 feet per second squared. So that is our acceleration at point C. So 4.64 feet per second squared. So that is for our A, which is searching for acceleration of point C. So V, the angular velocity and acceleration of the pinion A. So as you can see in the figure, we have point A. So that we will give angular velocity and angular acceleration. So go back to our solution. So we'll now go to another page. Go back to another page. So here. So we are now solving for letter B. So for B, the velocity V1 is determined. The velocity V1 is determined as the angular motion of the gear and gear A and gear B. So where is gear A and gear B? You can see it here. Gear A and gear B and A1 for tangential acceleration. This is only for their common point of contact. Thus, this will give us V is equals to R multiplied by the angular. So this is also equals to angular ni B equals a V all over R. We have given V, which is 3, of course, and we have R, which is 24. Convert it to conversion. We have 324 divide 12. Solve that. 324 12 is 1.5 rad per second. So nextly, we have the angular B. So the angular B is ATR. So here na lang. So acceleration tangential is, if we go back to the previous solution, it's 1.125 feet per second. So that's the value. So 1.125 all over R, which is 24 divide 12. Solving that, we now give 0.562 rad per second square. So that's it. So we have angular B and angular, this is the alpha B. So after that, therefore, from V1, we have RA, angular A, RB, angular B, alpha 1, RA, alpha A, RB, angular B. So we have uh, angular A is equals to RB all over RA angular B multiplied by angular B. This is 18. RB is 18. 18, convert this to 12, 6, 12. And our angular WB is 1.5. So, simply multiplying this. So, this will give us 8, 12, 16, 12. Multiplied by 1.5, we now have 4.5 rad per second. So you can see in the figure, it is counterclockwise. So it is counterclockwise direction. So other than that, we will now get our angular acceleration. So this is for angular acceleration and this is for angular velocity. Since in the problem, it is as the angular velocity and acceleration of point A. So this is point A, point A. So this is for RB, RA, angular B. So same lang. So 18, 12, 6, 12, angular B, which is 0.562. So simply computing the pass and changing it to 0.562. Okay, we got 1.688 rod per second squared. In what direction exactly? Okay. It's counterclockwise also, of course. Counterclockwise. So that's it for the answer. You can solve it like this, but you can prefer graphically. So I'll be showing graphically. So you can simply put draw the figure, the pinion and the drum here. So let us draw the pinion and the drum. So it's here. This one. This is the pinion and this is the other circle. What is the measurement? It's 18.6. So if you're wondering, 18 plus 6. If you are wondering where did I get the 24, it is simply 18 plus 6. It's 24 inches. So that's the R. So other than that, we have here, this is our V1 and this is our A1 and this is our angular A and this is our acceleration A. So how about this one? So as you can see the directions, angular B, this is the angular B, and this is the acceleration B, this is the angular B. So other than that, we have here, this is our point, what is this? This is our point C. So I'm just referring the point C graphically. So we have for point C, where's my green pen? Where is this? For point C, we have here and here, which is the vector, and here. And then AT is equals to what? This is our acceleration tangential, which is equals to 1.125 feet per second squared. So if you're wondering where's the A normal, it's